Good evening and welcome to Math and Engineering Help Desk. This is Jeff helping you out on a Thursday night. As you can see, it is Pi Day, so it would make sense for me to post a video on Pi Day. Unfortunately, this particular video, nothing to do with pi, nothing to do with geometry, just a couple of proportional and linear relationships type questions to help students review for a test. If you are taking a test on proportional linear relationships in a pre-algebra class or an 8th grade Common Core math class, then this test review can certainly help you out with those. Okay, so we're going to go through about 21 problems, and the sequence of problems basically 1, 2, and 3. So we're going to kind of go through each of these and talk about how we would approach these problems and go from there. So the first set of problems we're going to be doing deal with unit rate. So if we're doing unit rate, we are going to be basically determining what is the amount per one of the second amount. So in the first situation with LeBron James scoring 124 points in 4 games, we would be finding a unit rate that would be in points per game. Okay, so in order to find out what that is, we would take 124, which is the amount of points he scored, and we would divide that value by 4. So we do 124 divided by 4, and if we complete that properly, we would see that he scored 31 points per game. So the answer here would be 31, and then we would say points per game would also be the unit of our answer, 31 points per game. Situation number 2, Spencer earned $100 in 5 hours. So once again, in this case, this would be dollars per hour. So how much money you would make per hour would be the unit of this answer, and then we would do 100 divided by 5 to figure that out. So if I go 100 divided by 5, let me change there we go. That would just be 20. So the answer here would be $20 per hour. So that's number 2. And then for number 3, Emily drew 27 pictures in 9 days. The unit rate here would be pictures per day. I almost said game. And it would be 27 divided by 9. So if we just carry that simple operation out, that's not too hard. Our answer here is 3 pictures per day. Okay, so that's how we do unit rate. Unit rate basically is just taking first quantity that's described, which usually is a dependent variable of some sort, and then dividing it by how many instances of that variable that occurred. So in each of the 3 of these situations, points per game, dollars per hour, pictures per day would be the units of those unit rates. Okay. For number 4 and number 5, we have tables that are provided here, and we have to answer 2 questions for each of these tables. The first question is, what is a proportional relationship using y equals kx format, and what is y equal when x equals 15? So this is not too hard. Nothing that's gonna be too difficult. These are all proportional relationships, so you're kind of provided that. Number 4, it's evident as a proportional relationship because you have 0 and 0. And so what you really have to do here is you have to pick any value, any row really, and do a division possibly, and maybe not even at all. So if you recognize in number 4 that 1 and 6, if x is 1, y is 6, that right there is what the unit rate happens to be. And the unit rate, the k value in this case, is always going to equal the y divided by the x. Now this only works because it's a proportional relationship, because when there's slope involved, we obviously have to do a different formula to do this. But we can find the k value in any proportional relationship if we just simply take a y value and divide it by its corresponding x value. So 6 divided by 1, that's obviously 6. So if the k value is 6, that means that the proportional relationship for this first table here is y equals 6x. So now that we know that y equals 6x, well, what would y be if x equals 15? So what we would do here is we would substitute in 6 times 15, or 6 times 15 right there. X would be 15, and we would just do some simple math, and we would find that y equals 90. So that's the first table, so it takes care of, that's answer part A right here, and that's the answer for part B right here. Let's do the same thing with number 5. However, you'll notice here in number 5, we have a slightly different situation, and that is that we don't have a necessarily unit rate, but once again, we can pick any 2 values, any 2 corresponding values. And also, I just want to point out that So obviously, if I were to use this 0, 0 row, this obviously would not work because you can't divide by 0. So always make sure that when you pick a table of values that's a proportional relationship, that you use a non-zero value for x to get your answer. Okay, so anyway, now that we're back to this number 5 here, so we have to do the same thing. We're going to pick any of these rows. We could pick any row we want. We'll pick this one right here, and if you're astute, you probably already realize what the k value is going to be here. So since, again, we would do y divided by x, this would be 60 divided by 6, and 60 divided by 6 is just 10. So that means that since the k value equals 10, k equals 10, therefore we would conclude that y equals 10 times x, or 10x. And then once again, what do we determine here? We have to determine what y equals when x is 15. So it would be 10 times 15, which means y equals 150, which makes sense. So that takes care of number 4 and number 5. Now, here is a situation where we have another proportional relationship, but we have to take an extra step here. In this problem here, we are keeping statistics for a soccer team, and we realize that when they have 30 shots on goal, which means that they try to score a goal 30 times, they end up scoring 2 goals in a game per average. Okay, now the only thing I can see here is we actually would probably want to rewrite this problem slightly. In that slightly problem here would be that we would want to indicate what x and what y would be. So the way it's written, when we have 30 shots on goal, you would have 2 goals in the game on average. That means that our shots on goal is y, and our goals in the game per average is actually our x. Okay, so so that means that we're going to have 30 shots on goal for every 2 goals that we score. So y is like that. So basically, that means our proportional relationship is going to be, since k equals y over x, that means that we're going to have 30 y over x. That's the y. There you go. Sorry, I'm going to be kind of, just doing the old mouse handwriting like I usually do. That's a staple here at Math and Engineering Help Desk. K here, let's put an equal sign in there. There we go. Y over x. So that means that we're going to be doing 30 divided by 2 because it's 30 shots on goal compared to 2 goals scored, which means 30 divided by 2, that equals 15. So this means, in context, k equals 15. The format of the equation here would be y equals 15x. So in context, this 15 here means that for every 15 times you fire on the goal, you will actually score a goal 1 time, right? So 15 shots on goal per goal, 15 shots per goal basically is what it means. So basically how many goals you have would be how many shots on goal you would take, the way this is written. Now, the other way that you could also interpret this, of course, would be 1 over 15 if you did it the other way, goals per shots on goal, which doesn't make as much sense, but it is what it is. Okay, so we'll use this graph now. What we have to do here is we're going to have to explain what our intervals are going to be. Well, because our slope, our k, is 15, we want to go by something that's realistic enough on the y-axis. And matter of fact, I've kind of instructed my students to, there's nothing wrong with going by what it says for your k value on your y-axis, especially when it's a number that's greater than 1, which obviously a lot of proportional relationships would be. So this would be, so if I go by 15, I'm going to say, well, here, you know what, let's even space it out a little bit more. Let's say this is 15 right here. And if that's 15, then we're going to make this, every other line would be, 30. So that would be 30 here on this line. And then this next line would be 45. And then the next line would be 60 and so forth. So we don't have to label every single one. And then for our x-axis, we can go by 1 because every, x is 1, then y would be 15. So we'll go by 1 on the x-axis. Every single one here will be 1. So I'll put a 2 on this one. And then just to further emphasize this is a 4. So make sure that when you're doing your graphs, if there's no intervals provided to you on the graph, that you give the intervals itself, right? So now let's plot a couple of points. If y equals 15x, that means if y equals 2, if x equals 2, y would equal 30. Let's use a thicker point and let's change the color. Let's see, maybe a little thicker than that. Let's go super thick. Yeah, it's a little too thick. Maybe not like that. It's a little too thick still. Very, very picky, this thing. All right there. That's very thick, but we'll go with that. If x equals 2, y equals 30. So if I keep going, maybe if x equals 4, y would equal 60. So if I'm here, then that would be 45. Then up 2, that would be 60. And then that looks like a pretty good amount of data for our linear relationship. So if I start here at my origin, since it's a proportional relationship, it would always go through the origin. So that would be a pretty acceptable graph right there to take care of business here. Okay, so for the proportional relationship, y equals 15x, graph that relationship, you would have to just come up with a couple of values. Given value is obviously one that you can certainly plot. I would plot a third and a second. The origin would be the second value, and the y would be the third, a third value of some sort for x, just to give you a good guideline to draw your graph. Okay, so that takes care of the proportional relationship section. Now let's move on to the linear relationship section. Now this page, I told my students today that, and actually I've been telling them all week, that this is the section right here that you should get every question right, because this is pretty straightforward. If you've got equations that are already written in slope-intercept form, then you know where the slope and where the y-intercept happen to be. So with number 7, if y equals 2x plus 4, the slope, which our letter m indicate here, would be 2, because that 2 is the coefficient of x. So if m equals 2, and then the b value, excuse me, which is our y-intercept, that would be 4. So for number 7, m equals 2, b equals 4. For number 8, we have negative 4x plus 3, so the m here is negative 4, and the b value is 3. And then for number 9, we have 3 over 2x minus 5. So our slope is 3 over 2. I'm just going to write it like that just for save time. And our b value this time, since it's minus 5, we got to write negative 5 as our b value. So don't forget to look at the signs as well, like what we did here with m and what we did with our b here. Now, if we do it the other way, what if we have a situation where we have the slope of 3 and a y-intercept of negative 5, and here we have a slope of negative 7 and a y-intercept of 20. So if we're doing this, we're going to now come up with an equation that uses this information. Okay, well that's nice and easy. Since it's y equals mx plus b, we just have to take the value it gives us for slope and the value it gives us for the y-intercept and just type in y equals 3x minus 5. Now, of course, you also could write y equals 3x plus negative 5. That would be acceptable as well, although it's more commonplace for us to write that as subtraction just to save, a little bit of character space. With number 11, a slope of negative 7 and a y-intercept of 20. Once again, the same kind of thing here. We just write y equals negative 7x plus 20. We just take our slope and our y-intercept and we plug it in, and we're done. That's it. Set it and forget it. That's it, right? So that's how we do those particular problems. Now let's move on, and we're going to now enter the realm of graphing. So we've got linear equations provided, and what we're going to do is we're going to fill in a table of values, and at the same time we're going to use that table of values to plot and graph this. Now, I just want to point out that there is obviously a way that you can graph this without using a table of values, but just to make sure that everyone's on the same page, providing the table is still good practice, and make sure that you are comfortable plugging values in and getting an output value. So here's our starting values, negative 1, 0, 1, 2. We're going to use these for this equation. We're going to plug in each of these values into this function right here. We're going to plug them in for x, we're going to get a number, and we're going to put it in for y. So with x equaling negative 1, that means we're going to do negative 3 times negative 1. Let me write that over here just to kind of show you. We're going to do negative 3 times negative 1, and then we're going to add 4. So if we do that, this is just for this one right here, this is going to be positive 3, right? Because negative 3, because a negative times a negative is a positive, so that's going to be positive 3, and then that would be 3 plus 4, which is 7. So our table of value here would be 7. If I keep going, let's just knock out the rest of these table of values. If my x is 0, that's 3 times 0, which is 0, plus 4, which is 4. If I have x equaling 1, that's negative 3 times 1, which is negative 3. Negative 3 plus 4 is positive 1. And then with 2, negative 3 times 2 is negative 6, plus 4 is negative 2. So as you can see also, which makes sense, another thing you can look at here, since these x's are going by 1, our slope says it should go by negative 3 on the y. So every time we go down, we're getting negative 3 each time. We're going down 3 each time, which is also important. Okay, so let's plot these points. Let's go with, we'll go with this right here. Let's go with blue this time. So once we get the table of values, we're going to go over to our graph, and we're going to plot the 4 points that we have on here. So at negative 1, comma 7, that would be right there. At 0, 4, that would be right here. At 1, 1, that's right here. And at 2, negative 2, that's right here. And then I've got my line tool, and I'll just draw a line. I'll start it right here, and we'll go through all of those points. Of course, you would use your ruler on your paper, and that would be acceptable. So there's your line. Just don't forget to connect the lines. Don't forget to draw all the way through the graph, and don't forget to include arrowheads on here. Okay, so that's number 12. Now, same kind of thing. Let's do number 13. We'll do the same value, same kind of system here. We're going to plug in the x value. We're going to, this time we have to do half of x and then subtract 3. So we have, a few more steps to do here. We have a fraction involved, so we have to do half of this value. So half of -2, if I cut -2 into two completely equal parts, it would be -1. So we'd have -1 minus 3, that's going to be -4. Okay, so there's our table of values entry there. If I plug in 0, now here's a shortcut, right? If I know it's 0, I know I'm just going to be left with the y-intercept, so that would be -3. If I do 2, that's half of 2, which is 1, minus 3, which is -2. And if I do 4, that's half of 4, which is 2, minus 3 is -1. Okay, so once again, we've got some points plotted here. We've got some coordinates to plot here, I should say. -2, -4, let's go right here. That's going to be right about here. If I go 0, -3, that's right here. If I go 2, -2, that's right here. And if I go 4, -1, it's right there. So that's 4 points from that table. And I can just go ahead and just draw a graph. I'm going to just extrapolate over here to this part right about there. And draw a line, see if I can hit all 4 of those points. That's pretty close. That's pretty close. Okay, so there's our line to mean this particular equation. Our y-intercept here is -3. And again, I just want to point out, you also could graph this without the table of values, but obviously for the purposes of this test, I would like you to fill in the values as well. But you can just plug in this case, the values, the y-intercept. If you know the y-intercept is 3, then all you have to do is use the slope to get to another point. So if you know the y-intercept is -3, you're going to start here, right? And then you're going to go up 1 and right 2 to get to another point. So if you're here, you can go up 1 and over 2, and then you'll be at the second point. And then you can keep doing that in as much as you want to get any more or any less points. And you also can go backwards too. You can go down 1 and left 2, down 1 and left 2. And so that slope here tells you what direction, how far up and how far right you have to use to get yourself into a good situation, into the next spot. So that's how we can graph as well as using a table of values. Okay, now we have a couple of situations, and we have a few equations, and then we'll be all done. So number 14, Sandra is saving money for a new phone. She initially had $110 saved already, and then saves $25 more every week from her job. There should be a more there. Question A says, write a linear equation in slope-intercept form that models the situation. We're going to let y equal the money she saved and x equal the weeks that she's worked. Okay, so if it's y equals mx plus b form, slope-intercept form is y equals mx plus b, we need to identify what's the b and what's the slope, right? So we read the situation. Is there a value that's fixed? Is there something that's not changed? Is something that's sort of starting, right? Well, in this case, yeah, there is. This number right here, this $110 that Sandra's already saved, this is giving you and telling you that this is your b. This is b right here, because that's sort of the money she's starting with. Which means also now, if we look saves $25 every week, you got to look for those key words. When you see something that's going to happen at a consistent amount of time or a consistent rate or whatever, that's usually, and most of the time, I would say that's your m, that's your slope. Okay. So in this case, our slope is 25, our b is 110. So a situational equation here is y equals 25x plus 110. So if we think she hasn't saved any money yet, from her job, then that's 0 weeks, 25 times 0, and we're just left with 110. So it makes sense. Now, for question B, we have to determine how many weeks it will take Sandra to save money at this rate if her new phone costs $360. So our question here is basically telling us that we want to know what x will be when y equals 360, right? So what will x be when y equals 360? That's basically what the situation is asking you. So we've already assigned, since x is weeks and y is the money she saved, that makes sense that you've got to deal with that, right? So what will x be when that? So what we're going to do here is 360. That's going to be our y. That's going to equal 25x plus 110. So our job here is we just got to solve this equation. We got to get what x equals by itself here. So the way we do that is we just move numbers over here. Let's show you one flowchart, because I showed some of my students this particular method as well, and I want to share it with you as well. So a flowchart method basically kind of tells you how to undo the steps and operations in the equation. If we start with the value we want, which in this case is x, I would say, okay, here's x. what's the first operation that happens to x? If I knew what x was, what would I do to it to evaluate the right side? So if this was an expression, the 360, we ignore it just for a second. If this was an expression, the first thing I would do to x here is I would multiply it by 25. So the first operation is multiply by 25. All right, now once we do that, we say, okay, then the next thing we would do is we would add 110. Now, if I took x and I multiplied it by 25, and then I added 100, what would I get? The answer here is I would get 360, because that's what's on the left side, right? And then, some occasions it's the right side. That's okay. On the other side, 360, right? Now, what I do here, why this helps me is because this gives me the sequence of steps that it takes to get what from x to 360. If I want to find out what x actually is, I can reverse all of these steps and reverse the order that they happen in. So if I take 360 and then I do the opposite of adding 100, which is subtracting 100, and then we stick a 0 in there, and then if I do the opposite of multiplying by 25, which is dividing by 25, that would equal my x. So in this case, that would equal my x. And so all I have to do here is do 360 minus 100. 360 minus 100 is 110, excuse me, I just realized 110. 360 minus 110 is 250. And then 250 divided by 25, that equals 10. So in this case, if Sandra saves for 10 straight weeks, she will have enough money saved up to pay for this new phone. If we think of it this way, if she works for 10 weeks, she's earning $250, plus on top of the 110 she already has, that she would get to 360. So there you go. So you can use this kind of flowchart method to kind of take the guesswork out in the algebra, showing the workout. This is a perfectly acceptable way to show how to solve this equation. Okay, let's do another one. Similar situation, similar area where we're going to ask some questions, but we'll have one extra question at the end. All right, so now we have the subscription rate for an online gaming service, and that requires you to pay $20 to sign up and then $30 per month. So once again, we're going to write an equation in y equals mx plus b form, slope-intercept form, that models the situation. This time y is going to equal the cost you pay, and x is going to equal the months you subscribe. So what we'll do here is we'll just say, okay, well, I understand, again, if I read the situation, it's $20 to sign up. That's sort of like a flat fee, right? And then $30 per month. So the 20 is going to be my b, and then 30 per month. There's another key word there. That per usually implies that you're dealing with a rate of change, which means you're dealing with a slope. So y equals 30x plus 20 would be a situation that models, the equation that models the situation. Now, question B, if you subscribe for 8 months, how much will you have paid? Well, in this case, x is the months you subscribe. So here we're giving you an x, and you're going to determine the cost, how much you've paid. So this is a simple substitution. You're just going to take 30 and multiply that by 8 and then add 20. If you do 30 times 8, that's going to be 240 plus 20, that equals 260. So you'll have paid $260 for 8 months of a subscription. And then for question C, if you have to end the subscription after paying over $700, how many months will you be able to use the subscription? So this is a situation where you're given a y. So once again, you can do 700 equals, and then you'd be doing 30x plus 20. So now here, if you're going to solve this, let's use a traditional work method here to show this. What we could do here is we could subtract 20 from both sides. So we can get rid of this 20. We always want to get rid of the terms that don't have an x. And then we subtract 20. Then we would see 30x equals 680. So if 30x equals 680, I would then have to divide both sides by 30 to get x by itself. So I do divide by 30 here, and then I divide by 30 here, and that's going to be, well, if I do 680 divided by 30, I know for a fact I'm going to get something that's going to be in the partial amounts, but 680 divided by 30 is going to be 22 2/3. So that means that if you subscribe for a 23rd month, then you would be over the limit on how much money you can spend, since you would only have enough. So you basically have to spend, you'd be spending less than $700, but if you go over, next month you'd be spending another $710, or not another, you'd be total of $710. So the answer to this question, how many months will you be able to use the subscription? The answer here is actually 22, because 23 would put you over, right? So after paying over 700, maybe the answer is 23. 23 would be acceptable, because it said after paying over $700. So once you hit 710, you are now paid over 700. You'd have to end. So the answer here actually would be 23. If you have to stay under $700, the answer would be 22. Okay. A few more problems to take care of, and then we'll be all set. We're going to solve some simple single variable equations below for the indicated variables. So let's kind of show the work as best we can. For number 16, the reverse order of operations, you'd have to reverse adding 4 and multiplying by 3. So we subtract 4, and after we subtract 4, we would have to divide the result by 3. So if I do that, and I'm just kind of going fast here because I think if you've seen the other two equations, you kind of understand the process at this point. If I subtract 4 and then divide by 3, that's going to give me 10 over 3, which is kind of an unusual number. You said most equations you would end up with a value that makes sense, but x equaling 10 thirds is totally okay. I can check this answer by plugging it back in. 3 times 10 thirds is 10. 10 plus 4 equals 14. So this is the solution for number 16. For number 17, this is a one-stepper right here. 12b equals negative 72. I'm just going to divide 12 on both sides. And then if I do that, that means that b is going to equal negative 6. So that's a quick one. That's a nice and easy one. And again, just to check it, if I do 12 times negative 6, do I get negative 72? Yes, I do. Number 18 is slightly tricky, but not too bad. Here you have a group on top that's divided by 2. The dividing by 2 here would actually happen last. So when you reverse, you got to reverse that first. So you got to multiply both sides by 2 first. That would be x plus 5 equals 200. Let's write that out for you. X plus 5 equals 200. And then here you would just have to subtract 9 as your last step. And then, subtract 5 from your last step. And that means your x value here is 195. Okay, so again, kind of a high value, but there's nothing wrong with that, right? And if I check my answer, if I have 195 here for x and I add 5, that's 200. 200 divided by 2 is 100, so this is the solution right here. So it's, again, a good idea to check your answers and make sure that they make sense. Okay, now for a couple of bonus problems. In these bonus problems, we have to isolate the y, and I will show you with a flowchart for one, and I'll show you with algebra for the other. So if we have number 19, and we're going to get the y by itself, the first thing that would happen is y is multiplied by 2. So start with y, right? It's going to be multiplied by 2 first, and then we're going to add 2x. So if we do that, that would give us 6. Right? So if I want to reverse the course here, I would have to subtract 2x from 6, and then I would have to divide both sides by 2. So if I write that, if I write negative 2x plus 6, which is like 6 minus 2x, but then divided by 2, that means if I divide everything by 2, that means y equals negative 1x plus 3. So that would be that equation here. There's a couple of shortcuts I'll kind of share with you in the future as well. When you have standard form, there's actually a really quick way to get this form right here from this, but we'll do that another time. For number 20, all we have to do here is just divide by negative 5 on both sides. If I divide by negative 5 on both sides, that's going to be y equals 20x divided by negative 5 is negative 4x, and then 5 divided by negative 5, that's negative 1. So y equals negative 4x minus 1 for that one. Here, this one's a little tougher. We'd have to subtract 4 and then divide by 2, right? Subtracting 4 would give you 3x minus 4 on one side. That would equal 2y. And then divide by 2 on both sides. That would give me 3 over 2x minus 2, and that would be my y. So y would equal, and I like to write the y first. So that's a couple of quick bonus questions. And again, the idea here is to get the y by itself. You can try flowcharting it. It is bonus, so just make sure that you don't lose too much sleep over this section. If this section is still confusing, there will be plenty of opportunities to get it to look normal. Anyway, thanks for making it to the end of this review. All you got to do here, I just want to mention thanks again for checking this review out and watching this video. There's a couple of videos ago I posted and I said every 2 likes that it gets, you get a point on your test. So right now, as of the recording of this video, there were 7 likes. You can go back to that video and add some likes up until 7 o'clock tomorrow morning, and then however many likes that is, that's divided by 2 will be how many points you get. So anyway, I hope you have a wonderful night. I hope this helped you study for the test, and I hope you do well tomorrow, and I'll see you then. Don't forget to be awesome.